So really super simple. And again, you can do this for a DSeq output, or you differentially express genes in single cell data, or anything else. Alright, for this tutorial, I'm going to be using output from DSeq 2, but it doesn't matter where your differentially expressed genes come from, as long as you have p-values and gene symbols. So I'm going to be using GSEA Pi, which is a Python wrapper for GSEA. So I imported my CSV of differentially expressed genes. I have around 1200. So the first thing we want to do is we want to rank these genes. And for that, we're going to make a new column called rank, which is going to be the negative log 10 p value times the logfold 2 change. So now we have our rank value. So let's sort the data frame by that. And then I'm also going to reset the index here. Although you don't really need to, I just like it being in order. And then I'm going to make a new data frame called ranking, and it's just going to be the gene column and the rank column. So now our data is ready to be passed into GSEA. If you don't have a gene list already in mind, we can use gene sets built into the program, like gene ontology. And to look at all the available data sets, we can do a gp, get library name, and we get this long list of different gene sets we can actually choose from. So the ones I'm going to be using is the Go biological processes. So let's call the actual GSEA function now. We're going to call this preres, and it's going to be gp.prerank, and then rank is going to be our ranking data frame, and our gene sets, we can just copy the gene set from this list here, and then we're going to set a seed just so that if we run it again, we get the same results, and this will take a few seconds. So now we have the results. If we call results, the output's this big gross dictionary of dictionaries where each key is going to be the term. So we're going to make a little data frame from this instead. It'll be a lot easier to look at. So I'm just going to loop over every entry in this dictionary and pull out a couple values like the enrichment score, the normalized enrichment, and the FDRP value. Alright, so now I have a data frame. You could include more in the data frame if you wanted to. But anyway, the first thing that stands out to me is that these top hits are negatively enriched. So it seems like the upregulated genes weren't enriched, but the downregulated genes were enriched for several terms. So let's just go ahead and do a GSEA plot of one of these. I'll just pick the very first one. Can't copy and paste it because it clipped it, so I just pulled it out like this. But see here, it's just a string, which we can use in the GSEA plot function. So we pass preres.ranking, and then the term, which is just going to be term to graph here. And then we need to pass a couple more parameters, which we can do just like this. And so we get this nice GSEA plot now. So I'm not going to go into depth into what everything means, but basically here's our ranked gene list shown here, starting at 0 and going to our 1200 DE genes. Everywhere there's a blue line, a gene from this Go term is at that position in our ranked list. And since we don't find any in the upregulated genes, or just a few, that enrichment score falls. And then once there's more genes here, it goes back up. So I'll show you an example what an enriched set in the upregulated genes would look like, and I'll also quickly show you how to do your own custom set of genes instead of passing a Go biological process. So we can make our own user set of genes. all it has to be is a dictionary of terms. So I'll just call this one set name 1, and then a list of genes. So for this, I'm just going to make my own random set of genes that's weighted from the ranked set to be enriched in the upregulated genes. Obviously, this is not part of the tutorial for GSEA, but I just wanted to show an example. Okay, so all I did was make a list of 100 genes that are much more likely to fall in the upregulated gene section. So now we can do something similar to earlier. Let's just copy this. So we'll do pre-res again, but instead of passing this, we'll just pass. Oh, I actually have to make this. So let me run this. We'll pass user set. And then if we graph that, the term to graph this time is going to be set name 1. And then we need to set name 1 here as well. So now we have a very highly enriched term in the upregulated genes. And then if you wanted to save any of these to a file, you can pass here out file name, OF name, and then whatever you want to call it, saved.png. So really super simple. And again, you can do this for a DSeq output, or you can do it for your single cell marker genes or differentially expressed genes in single cell data from ScanP or anything else in Python.